let's look at some limits at infinity. We're going to see that there are three distinct types of problems that we could be faced with when we're talking about a limit at infinity. Well, maybe not only three, but three involving what we call rational expressions, right? Polynomial divided by polynomial. So here we have limit as x approaches infinity. I'll just write it again. 2x cubed plus 7x minus 4 over x to the fifth minus 2x squared plus 4. Now note that when we just try to plug in infinity, which is to say plug in bigger and bigger values of x, we get infinity over infinity. That's going to be the case every time. Maybe there's a minus sign somewhere, but whatever. But what we want to notice is that here the lower power is in the numerator and the higher powered leading term is in the denominator. Remember, we care only about the leading terms. Everything else is not relevant. So what happens is we want to divide by the lower powered leading term, which in this case is 3. And this is going to give us limit as x approaches infinity of 2, right? Because 2x cubed divided by x cubed is just 2, plus 7 over x squared minus 4 over x cubed. And on the bottom, we have x squared minus 2 over x plus 4 over x cubed. Now, just to make a couple of observations, these guys are going to 0. These guys are going to 0. 2 is going to 2. And x squared is going to infinity. So what happens when we have a fixed numerator and an ever-increasing denominator? Well, we get a limit of 0. And that's our answer. It's 0. Note that when the numerator had a lower leading term than the denominator, lower degree leading term, we got 0. Just want to put that out. Next up, we have a situation where the numerator and denominator have leading terms of the same power, same degree. Right? Again, we have indeterminate form of infinity over infinity. So in this case, we multiply by the lower degree leading term, which, I mean, it's the same thing, right? It's both x to the 4. And in this case, what happens? Well, we get the limit as x approaches infinity of 4 minus 1 over x to the 4th, all over 7, oh, I guess it's just 7, right? Plus 3 over x squared plus 1 over x squared. Again, notice these guys go to 0. These guys go to 0, and we're just left with 4/7, and that's our answer, 4/7. So note that when the degree on the top was the same as the degree on the bottom, we had just the ratio of the coefficients. Anyway, let's look lastly at limit as x approaches infinity of 4x to the 4th plus 2x squared plus 1. 3x cubed plus 7x minus 12. And note in this situation, it's reversed, right? The higher degree is on top, lower degree is on the bottom. Okay? Now, maybe you know what this is going to be. Maybe you can reason with it, or maybe you can remember the problem we did in the video, the lecture video. But what we're going to do is the same as always. We multiply by the lower degree leading term, which in this case is x cubed. Right? So this is going to give us 4x plus 2 over x plus 1 over x cubed over 3 plus 7 over x minus 12 over x cubed. And again, note these guys go to 0, these guys go to 0, and we have 4x over 3. 3 goes to 3, of course. And 4x goes to infinity. And so our answer is infinity, right? If we have an ever-increasing number divided by a fixed number, our limit's going to be infinite. Right? And that's what we've got. So those are the three types of problems that you can have, right? A situation where here the higher degree was in the numerator, the degree is the same, or the higher degree is in the denominator. Think about what the answers are always going to be. That's all we've got.